Hello, I wanted to talk to you today about page 168 in your workbook. And on this page, it asks you in 3 separate sections to convert a quadratic in a certain form into a different form. So it's broken into 3 sections. The first one, hopefully you notice that these are all in the same type. All right, think about of the 3 types that we know, again, standard, intercept, and vertex form. Which type is that? Right, hopefully you said that it's intercept form. Again, it can't be standard form because it's asking us to convert it into standard form. It's also not vertex form because remember vertex form has only 1 parentheses in it, not 2. And then in the second part, it's asking us to convert these into intercept form, right? Again, of these, the 4 types here, or the 4 problems are all the same type, and that is what type? Right, hopefully you said standard form. Standard's the only one that doesn't have parentheses. All right, and then the last one, sorry, my desk is crowded here. The last one, again, it's 2 of the same type. What type is that? All right, hopefully you said intercept form again, same as the first one, the first set, but now it's asking us to convert it into vertex form. So before we start, let's write down the 3 different formulas for the 3 different types. So we started with vertex form, and vertex form was y equals a times x minus h squared plus k. Again, where hk was the vertex. If it was negative, flipped it up, left it right side up or flipped it upside down, or it also could stretch it or squish it. All right, so we notice that this has a parentheses and a squared around it. The second type was standard form. That was y equals a x squared plus bx plus c. It had no parentheses around it. And then the third type was intercept form, and that is y equals a times x minus p times x minus q. Oops. So it was in factored form, really. Again, this is not factored form because in factored form there would only be factors, and here we have just a plus k on it. Factors mean that they have to all be multiplied together. So when we've got that plus k, that ruins the factored form. So this one is in factored form. And again, we call that intercept form. Again, one thing we noticed is that they all have this a, that's the coefficient of the x squared term, even if it's not multiplied out. When it is multiplied out, it would always be the coefficient of the x squared term, right? So we're going to focus for just a second on these differences between them so that it helps us decide how we move from one into another. So again, convert the given equations, which as we stated are in intercept form. Oops, I can't spell and speak at the same time. Wow, I really can't spell. Intercept form into standard form. So we've got intercept form and we want it in standard form. All right, so when we do that, we're starting with something like this and we're trying to get something like this. So when you see problems like this and you're like, I have no idea what to do, I want you to just look at what the visual differences are, right? So again, this has parentheses, this does not. Really, that is the massive difference between the 2 of them. So when it's asking us to convert from this form to this form, it's really saying just get rid of the parentheses that you see here. All right, if we get rid of the parentheses and combine like terms, that's going to put it into this form. All right, so in this section right here, that's what we're going to do. So I'm going to do 9 and 11, and then you, for homework, are going to do 10 and 12 on your own. All right, so it's asking us here to get rid of the parentheses. Right, so you have 2 options here. You could distribute the -4 in first to the first parentheses and then multiply that binomial that you get by x plus 2, or you could do these 2 first and then distribute the -4. I'm going to choose to do multiplying these 2 together first and then multiply by -4. All right, so I'm going to leave this -4 here. And then I'm going to FOIL these two. So x times x, x squared. X times 2 is 2x. Negative 5 times x is negative 5x. And negative 5 times 2 is negative 10. All right. I'm getting closer. Again, I'm trying to get to this form right here. So I have gotten rid of one set of parentheses. So now it's just a single set instead of two. Before I distribute that negative 4 through and get rid of the parentheses altogether, let me combine like terms. That'll mean less distributing in just a second. So x squared minus 3x minus 10. All right, and now let's distribute. Negative 4x squared plus 12x plus 40. All right, so see how it is now in standard form, how we have no parentheses. It's got our a, negative 4, x squared plus b, which is 12, times x plus c. All right, standard form. Okay, let's do number 11. There's really no difference between the last one we did and this one, other than we're going to have a fractional value. So let's just see how that works. Okay, again, really here, it wouldn't have mattered that much whether I distributed the negative 4 into here first and then multiplied by the x plus 2, or did it the way I did. Here I'd say it's definitely going to make our life harder if I multiply that 1/2 through. So again, I'm going to focus on these two right here and multiply them out. So I've got 1/2, and then x squared minus 9x plus x minus 9. All right. Combine like terms, so 1/2 x squared minus 8x minus 9. Again, some of you have gotten fast enough and done enough of these now that you can skip right from here to here, and I'm thrilled for you if you can do that. So if don't feel like you have to write it all out, you can just go right to that step there. All right, now let me distribute that 1/2 through. So I'm going to get 1/2 x squared minus 4x minus 9/2. All right, so converting into standard form generally is pretty straightforward because all you're doing is removing whatever parentheses there are. Okay, let's move down to the next section. Convert the given equation into intercept form. All right, so again, these are all, so convert the given equations which are in standard form into intercept form. All right, this is going to be a little bit more difficult. It's very easy to get rid of parentheses. You just multiply everything out, but now it's asking us to now it's asking us to start with something that has no parentheses and introduce parentheses. Right, so think about how we might do that here. And again, I'm going to do 13 and 15, and then you're going to do 14 and 16. Right, so how could I introduce the parentheses that that show up in this form? So if you're struggling with that, think about what are P and Q. Right, if you remember when we did these, this was the x, these were the x-intercepts. All right, so these are the things that solve the equation setting this equal to 0. So y equals a times x minus p times x minus q. These are the things that made that equation equal to 0. So really, it's basically asking us, all right, if this were set equal to 0, how would it factor so that we would get something like this back? All right, so essentially what it's asking us to do is just simply factor this. All right. What would you do in this one then? Now, you might say, well, if I were to solve this, I would just divide everything through by negative. But again, don't forget that we can't lose this. When we multiply it back out, it has to turn right back into this. So if I were to do that, I need to factor out that negative, even though if I were solving, I would get rid of it. So if I did that, I've got x squared plus 7x plus 6. here, I would do negative, and then this is just an easy general trinomial, so this is going to give me an x plus 6 and an x plus 1. All right, that is now in intercept form. So that would be, we would have done what they asked us to do. All right, number 15. This one's a little bit strange because we've got this really weird negative 3/4 out here. And again, if you notice up here that neither of these x's have coefficients in front of them, it's just assuming that it's a plain old x minus some number, x minus some other number. Which means that we need to turn this somehow into something that is, again, like this, an easy general trinomial that we can factor, which means that negative 3/4 has to go. That is the a, right? Again, this is in standard form right here. That is the a, that negative 3/4 is the a of right here, which has to become the a of right here. So we need to first factor that out. Again, this is going to be really uncomfortable because we don't usually factor fractions out, right? So let's think about what that would look like if we factored that out. All right, well, hopefully the first one's pretty easy, because if I'm factoring negative 3/4 out of negative 3/4 x squared, you should say that just x squared is left over. All right, now let's do the same thing again. Again, what we're doing is we're just dividing each term by negative 3/4. All right, so negative 3/4 divided by negative 3/4 is 1. But now we need to do the same thing right here. So we've got to take 3 and we've got to divide it by negative 3/4. All right, so let's do that here. 3 divided by negative 3/4. So here I wrote it vertically. Here I'm writing it horizontally. And now I'm going to do 3 times negative 4/3. If I do that, these cancel, and so I end up with negative 4x right here. All right, if that's a challenge for you, go back and watch that again, but I'm just taking and I'm dividing 3 by negative 3/4, and when I do that, I get negative 4. All right, we're going to do the same thing again for 9. Now I'm going to take 9 divided by negative 3/4. I'm going to do keep change flip, so this is 9 times negative 4/3. These 3's cancel. I'll be left with a 3 right here, and this becomes negative 12. All right, so again, it's weird to factor that out. It doesn't look like they have a negative 3/4 in common. We're forced to in order to turn it into intercept form, and it's actually quite lovely when it turns out that way. All right, let's go and keep factoring, because now what we have is an easy general trinomial. All right, so this becomes x and x. I'm looking for two things that multiply to 12 that subtract to 4. So I'm going to go with negative 6 and positive 2. All right, multiplying those gives me negative 12, and adding them gives me a negative 4. Right, and that is now in the intercept form that we were looking for right here. A, which in our case is negative 3/4, x minus p, in our problem it's x minus 6, and then x minus q, that's x plus 2. All right, you're going to do 14 and 16 on your own. Again, you have to factor out that coefficient of the x squared because it becomes the a, right? Again, notice that these are two factors of an easy general trinomial because there is no coefficient in front of either x. All right, it got factored out as the a. Okay, convert the given equations into vertex form. This is new. Think you can do it. We're going to do one of them together, and you will be able to do the other one on your own. All right, so it's asking me to convert the given equation, which is in standard, which is in intercept form, into vertex form. All right, the given equations, which are in vertex form, I'm not going to change that. All right, and change it into vertex form. Okay, so to get from intercept form right here into vertex form right here, first of all, you might say, well, we don't need to get rid of parentheses because this still has parentheses right here. But actually we do, because this has an extra thing added at the end, which we don't have here. And this parentheses is really the same factor twice, or the same parentheses twice. These are two different ones. This, again, might look like a real challenge here, but let's just write down what vertex form is. So it's asking us to get it in y equals a times x minus h squared plus k form. All right. So let's just go through and see if we can figure out what a, h, and k need to be in order for us to fill in here. So as we're looking at this, are any of them obvious to you? Can you tell right away, looking at that, what a is, what h is, or what k is? All right, hopefully you say, oh, a is 1, because there's always an implied 1 out here, and that's where a should be. So this, if we're filling in things, this we're going to fill in with a 1, or you could just leave it blank knowing that we don't usually write a 1. Okay, whoops, I filled in a k instead of a blank. All right, so then the next thing we need to do is we need to find h and k. So what are h and k? What do they stand for? Not what are they, that's what we're trying to find, but what do they stand for? Hopefully you remember that h and k stand for the x and y coordinates of the vertex. Right, so it's asking us to fill these two spots in with the coordinates of the vertex of this quadratic. So how do we find the vertex of a quadratic that's in intercept form? Again, if you forget, you can take out that sheet that we've been kind of using as a cheat sheet that had the 3 different forms and the 3 different types of everything on there, or maybe you just remember what it is. So if you want to go get it, pause the video and come back so that you have it with you. All right, so I'm going to remind you here, hopefully you've got your sheet and you've already looked, but to find the x coordinate of the vertex, which is going to be h, we just take the p value and the q value and find their average. And again, the p value and the q value are always the opposite of what they say in the parentheses. So here, this is a positive 1 plus a negative 7 divided by 2. All right, so 1 plus negative 7 is negative 6, divided by 2 is negative 3. So this is minus a negative 3. All right, now how do we find the k value, or the y coordinate of the vertex? All right, you would plug that back into the original equation. So now we're going to say that the y, or k, is going to be negative 3 minus 1 times negative 3 plus 7. And remember, we said something really cool should always happen here if we have the correct x value for our vertex, and that is these should always be the same number but opposite signs. So negative 3 minus 1 is negative 4, and negative 3 plus 7 is positive 4. So we know we have the right coordinate for the vertex because these are opposites of each other, negative 4 and positive 4. So we get a negative 16 right here. All right, so we're just going to take this and clean it up then. All right, so I'm not going to write the 1. This is going to be x minus a negative 3, which is just x plus 3 squared minus 16. All right, so we have to figure out what the a value is, what the h is, and what the k is. Again, the a is just a straight transfer down here. The h is we use the formula p plus q over 2. And then to find the k, we just did f of p plus q over 2. All right, so you're going to do the evens on this page, and then you're going to submit the whole thing to me. All right, let me know if you have any questions. Bye.